Hey, this is Steven from LegitTechTutorials, and welcome back to Intro to Computers. Today we're going to be talking about drives. So drives, also known as hard drives, are what you use to store all your information, to basically save your information, so the next time you turn on your computer, it is still there, and you can now access it. So there are two types. There's HDD and there's SSD. HDD stands for hard drive disk, and SSD stands for solid state drive. Now, a hard drive disk is exactly how it sounds. It's got it's a hard drive with a spinning disk inside, a read head that deposits electronic charges on a magnetic platter that you're then able to read with the read head and discover your data. And an SSD is basically a big piece of RAM inside that you use, and it's a lot faster, but there's a lot smaller storage on those. Alright, so here are the different types of hard drives here on Newegg. You have desktop, laptop, enterprise, and hybrid hard drives. Now, hybrid hard drives we're going to skip over because those are basically a combination of hard drive disk and SSD all in one. The technology is still rather new, though, so it does have some hiccups here and there as far as keeping the data and not failing. Basically, what happens with those really quickly, I'll go ahead and give you a rundown, is those guys, they have a piece of SSD RAM that's in there as well as a hard drive disk. And your most used applications are cached on that small SSD portion of the drive, so that when you want that piece of data, you could get it very, very quickly. So you have the plus side of an SSD and the plus side of large SSD speed and the plus side of large storage possibilities. Actually, let's go ahead and jump into that and take a look real quick. So for example, if I wanted to show you this guy right here, this 2 terabytes, and it will tell you exactly what will be on that. Okay, so it says solid state hard drive with NAND flash memory on the inside. So it has and it's a little bit thicker, I think. So you could also get this in laptop form, which is usually probably what you would use it for. So let's go ahead and take a look at the specifications here. So it's a bare drive. I'm guessing that so that means that it comes with no cables or any mounting brackets or anything like that. It's SATA 6.0, so like you saw on the motherboard, you have SATA 3.0 and you have SATA 6.0, which is, those are technically SATA 3, right? SATA 3 is 6.0 and SATA 2 is 3.0. Capacity is 2 terabytes plus the 8 gigs of NAND. As you see, very, very small amounts of SSD storage on there. Not really going to improve your speed all that much. 64 megabytes of cache on it, but 8 gigs could store, Premiere Pro or maybe a small video game or whatever on there. Average seek time less than 12 milliseconds, so less than 12 milliseconds to pull your stuff. Average write time less than 12 milliseconds. And this is a 3.5, so this goes in a standard 3.5 drive bay. And yeah, so that's. It says, of course, faster than a traditional hard drive disk because it's got the NAND. So it's got SSD-like performance just for those 8 gigs of NAND storage on there. Okay. So that's the basic of those. Let's go ahead and jump into desktop hard drives. We're not going to really go over enterprise hard drives because this is around just basic computing, which that guy is also a viable option. The 8 gig NAND. If you're the 8 gig hybrid, they call those hybrid drives. So let's go ahead and jump into a Western Digital now, and let's go ahead and look through the names. So basically, in here, this is all written inside the name, and the other one didn't have as many specs as this one. So I'll explain those extra specs as well, and why you should definitely know about those specs when you're looking up your hard drive. If you have to look somewhere else rather than Newegg for the information, do so. So this is a Western Digital blue version. Blue version is the middle ground. So they have green, blue, and black. Black is performance, blue is middle ground, green's economy. So it's like, energy savings, stuff like that. So this is a blue drive, and it's a 1 terabyte storage, so you could hold 1 terabyte of data. So 1,024 gigabytes, right? then it's a 7200 RPM. So 7200 RPM really goes towards the speed. So if you have a 64 megabyte of cache and a 7200 RPM, and you found another one that has 64 megabyte of cache and 10,000 RPM, then that one's going to be obviously faster. And then you have a SATA 6, which is SATA 3, right? So always go with that. That's the new norm. That's the new standard. Very, very fast. And it's a 3.5-inch hard drive, internal hard drive for a desktop. All right, so exactly the same thing you see in here. It's a SATA 3, which is 6.0 gigabits per second, 1 terabyte, 7200 RPM, 64 megabyte for daily computing, standard daily computing. So this is for the average computer. You get a blue drive, and red drives are NAS drives, which those are for storage, which we're not really going to go over. So here's another one. 7200 RPM is the main standard. They also have like 5400. So you want to try to avoid the 5400 because they're a lot slower than the 7400. But as you see, almost the same standards here. So also the black and the blue, the difference is the controller. So also the controller that they use to control the memory writing, memory reading will determine the performance. So definitely look up benchmarks at some places between different hard drives and find the best one that you want. But like I said, for Western Digital, it's pretty laid out. You have the green, which is the economic one. You have the blue, which is the middle ground, and then you have the black, this one's a black. And you see very, very good reviews on this. But very expensive because it's a 4 terabyte hard drive. It's a standard 3.5-inch drive. As you see, not really too many specs on this stuff. Let's look at a Toshiba. So this is a 7200, which is the standard 64 megabytes cache. Average latency 4.17 milliseconds. So yeah, it's pretty much average. Most of these are pretty close together. Let me see. As you see here, we have different speeds. So here's a Velociraptor. I have an old Velociraptor that was 3.0 gigabits per second. This guy is very, very fast. Very, very fast drive. And it also has very, very large storage. So the faster the speed you get, the faster rotating speed, the quicker it is. And as you see, it's still 64 megabyte, but it really helps because of the rotation speed. So if I go back again, then we have lots of other speeds, like almost like 15,000. So there's your 15,000 drive, and then you can see the price, how the price jumped way up for just 300 gigs. So very, very high performance hard drives here. Definitely good for, if you're doing a video production and you want to store massive amounts of data on larger drives that are very, very fast. So that is the average, and as you see, it goes mainly up 64 megabyte, and then you have the SATA 6.0, SATA, where's the other SATA? I think they stopped selling them, but they have SATA 3.0s as well. So you want to make sure that you get SATA 6.0. So let's go ahead and jump into solid-state drives. So solid-state drives almost like a stick of RAM that has very, very high capacity. Rather than just 8 gigs, you can get, as you see down here, up to 1 terabyte even on a drive. Going to be very, very expensive. And then you have different form factors. So mSATA is for very small devices, almost like, what was it called? The NUC, the Intel NUC, next unit of computing, etc., etc. You have PCI cards, which are very fast, Thunderbolt, USB, M2. So the main ones you're probably going to get is look at SATA 3 drives, as I'll show you the PCI would be the other one you would look at. Very, very expensive for that size of drive. So as you see here, very, very expensive for very small storage. So $90 for 120 gigs. So you'll see around $1 a gig or less now. Starting to go down in the technology, so it should be less than $1 a gig, but it's still pretty close to $1. As you see, these are smaller drives, so this by standard usually could fit in a laptop, as a laptop has a 2.5 inch. So that's why you see on those cases that we looked over is that they'll have 3.5 millimeter drive bays that you could adapt down to 2.5. And so we have 120 gigabyte TLC. It's talking about the memory. SATA 3, which is 6.0. And then here it talks about the controller. So here's where the controller also makes a huge difference, as the speed is a lot quicker, and there is technically no spin speeds. So it all depends on the controller and the type of RAM that is, the type of memory components that are inside. And also the sequential read and sequential write is usually compared to each other, and the 4K 4 kilobyte random reads, random writes. Usually the higher it is, the faster it is. And then also the operation. This is median time between failure, I think. Here's the operating temperature and operating humidity. So let's go ahead and look at a different one. This is a Samsung. Let's go ahead and look at a Muskin one. This is a Kronos. Okay, so it's 240 gig. Let's look at the price, 114. The other one was 89 bucks. So once you start jumping in storage, it doesn't increase too much. So it's like there's like a standard minimum level is like probably 80 bucks, 60 bucks just to get one of a very small size, like 32 gigs or whatever, and then it just starts to increase at a slightly lower scale rate. And here you see this one is extremely fast on its reads and writes. So you want, like I said, for more performance, you want max sequential reads higher and max sequential writes higher. So, you know, if you found one in the 1,000 megabyte section, obviously you want to get that in each of these. And then you see the IOPS here. You want a higher IOPS, lower seek time, and longer median time between failure. So a higher number here, higher number here, higher number here, higher number, smaller number. And this is a SandForce controller, SATA 3, so that's 6.0. 7mm height, width is 70mm, depth is 100.5mm. I'm pretty sure SATA 3 is 6.0. Anyways, because that's still pretty. Okay, so let's go ahead and compare these. So obviously higher IOPS, but slower maximum read. Definitely slower IOPS. Very fast IOPS here, and decent read and write speed, same as this, probably because you're using the same controller. This is used TLC, this is MLC components. So that is basically it. So let's go ahead and, so just compare these and find one in the storage that you like. Find the maximum sequential, Find the maximum sequential read, that's the highest, and the max sequential write. Look up some benchmarks on some tech websites that do benchmarks of all these and benchmark them together, and find the one that's the fastest, and go ahead and pick that one up. That's basically all you have to do. Okay, so let's look at the PCIe, which is probably the other one you're going to get, and as you see, very, very high in cost for what you could get. As the reason why is it has a lot better write speeds. As you can see, it's like double of some of those other ones. It was like 540, I think, for that Samsung, and this is pretty close to being almost double. So it's a lot faster when you're transferring over just the standard PCI Express slot. So that's the PCI Express 1X, I believe. And that's just PCI 2, and they're further improving this type of technology. So here you see 480 gigs, a lot more than $1 a gig. Here's another one, almost $2 a gig. And this one here is, $1.50 per gig. Here's an OCZ Revo drive, pretty popular, still over $2 a gig. But let's go ahead and take a look at the maximum reads and writes and the IOPS. So as you see here, whoa, smoking, up to 1,000 megabytes per second read and up to 950 megabytes per second write, and up to 45,000 IOPS, up to 80,000 IOPS, and very, very long median time between failure, or whatever that actually is. So definitely a lot more expensive option, but a lot higher performance. So standard person probably wouldn't spend $500, especially a gamer that could spend that on a pretty badass video card. So usually you're gonna want to stay in the realm of SATA 3 internal drives. So just go ahead and look through there and find the quickest one that you can find. And also look on reviews. Look up the reviews on Newegg and look at the benchmarks and find the fastest one that you could possibly get. So between the two types, the hard drive disk and solid state drive, you definitely want to think: do I want performance or do I want storage? So for my particular, or do you want to get a hybrid drive where it has more of storage space and a little bit of SSD? So what I did with my particular setup on my computer is I went with an SSD for the operating system, SSD for my games and main applications, and then a standard slower hard drive for a standard video editing hard drive and a media hard drive, so that I could store data on there, so it doesn't have to spin up for so long. So it might even be a good idea if you had something in the hybrid drive that was up to 16, 17 gigs or something like that. Then you might be able to store some of your operating system on there. So most of them, I think, only have 8. So yeah, so definitely research this technology and figure out which one you want. This was just a basic rundown to get you introduced to it, to get you excited about learning more and doing more research. And we'll go over these a lot more when we start to build a computer of our own. And yeah, so this has been Steven from LegitTechTutorials. Thank you for watching my tutorial video. If you like this video, please subscribe for more videos like it in this series and other series as well. I will eventually start working on a book or a manual for this subject, so be on the lookout for that guy, and subscribe for more videos, and I'll see you guys in the next video, and take it easy. Peace.